Thinking outside the box tackles the problem of generative object compositing. Object compositing consists of, given a background image and an object, generating a new image that incorporates the object into the background. Most generative models require a mask as input and constrain the generation in the area delimited by the mask, instead of performing generation in the entire image. This leads to several limitations. First of all, if the bounding box is not completely accurate, it can easily lead to highly unnatural images where the composited object is too big, too small, or slightly displaced. Additionally, since the generation is constrained inside the mask, the model lacks the ability to generate shadows or reflections that go beyond it and match the lighting of the image. Lastly, since the model never sees the entire background but only a masked version of it, the content cannot be preserved. Our paper addresses those limitations by introducing a novel task, unconstrained generative compositing, and proposing a diffusion-based model that performs unconstrained generation. This model accepts as input a full background image, a view of an object and an optional mask, and returns both a composite image and a binary mask indicating the generated object pixels. When training, the provided ground truth mask is slightly perturbed for avoiding the model to learn a one-to-one correspondence between the object and the mask. Instead, it learns to use it as a rough guidance for location and scale, while allowing small adjustments that increase realism and quality of the generated image. Additionally, with 50% probability, we'll replace the input mask for an empty one for ensuring the model can successively perform mask-free. We additionally incorporate a multi-scale approach into our generation pipeline for improving our model's ability for generating natural and diverse object scales. Training our model for performing this task requires paired data of object, mask, background, and ground truth that can be complicated to gather. We provide an automated pipeline for obtaining this paired data from any image without requiring additional information or any restriction. We apply this pipeline on over 900,000 images from Pixabay and use the output for training our model. Therefore, at sampling time, if no mask is provided, the model can automatically place the object in diverse natural location and scales. At the same time, when the user does provide the mask, it is used for guiding the location and scale of the object in the generated image, showing that it is able to adjust any bounding box misalignment if needed. Since the generation is performed in the entire image and not restricted by the bounding box, it can also synthesize object effects going beyond the bounding box. And lastly, since the model sees the entire background and not just the masked version of it, no information is lost and all background details can be preserved. We provide different evaluations as well as comparisons to state-of-the-art models, finding that our model outperforms existing object placement and object compositing models in various quality metrics and user studies. For more information or more details, feel free to read our paper, visit our poster, or contact us. Thank you very much.